So the problem read that air flows through the tube at a rate of 1,200 centimeters cubed per second. Assume that the air is an ideal fluid. What is the height h of mercury in the right side of the U-tube? So first I'm writing down what I know. So I know what the volume flow rate is, V, which is equal to 1,200 centimeters cubed per second. And that is equal to 0.0012 meters cubed per second. And so what I don't know, my unknown, is the height, which is what they're asking us to find. And so we know that because of the difference in height of the liquid of mercury in the tubes, that we can use the difference in pressure equation, which says that P1 minus P2 is equal to density times gravity times the height of the liquid. And then we could isolate H and say that H is equal to P1 minus P2 divided by the density times gravity. But in this equation, we don't know what P1 minus P2 is equal to, so that's another unknown. But I think I can use Bernoulli's equation because it relates P1 and P2, so P1 plus 1/2 density times volume squared plus the density times gravity times Y1 is equal to P2 plus 1/2 density times second volume plus density times gravity times Y. But now with this equation, I need to find V1 and V2, so I'm writing that down in my unknowns. And to find the value of V1 and V2, I could use Poiseuille's law. I don't know how to pronounce it. But yeah, I could use this law because we also have the volume flow rate, which is acceleration, which is the value of dv over dt. A stands for acceleration, and we don't know what that is yet, so I put that down in my unknowns. Don't know what A1 or A2 is, since they're two parts of the tube. But I do know that area is equal to pi times radius squared. Okay, so I'm going to begin by finding the area of the larger part of the tube, A1, which is equal to pi times radius squared. And that is equal to 3.14 times 10 to the negative 4 meters. Okay, now that we have the area, we can use the discharge rate equation and solve for V. So V is equal to the acceleration dv over dt
divided by
times 1 divided by the area. So the acceleration is the discharge flow rate, which we were given 0.0012 divided by the area we found, which is 3.14 times 10 to the negative 4. And that is equal to 3.382 meters per second. So now we can begin finding the area of the other side of the tube. So A2 is going to be equal to pi times 2, because that's the radius of the smaller side of the tube, times 2 times 10 to the negative 3 meters squared, which is equal to 1.256 times 10 to the negative 5 meters squared.
Then we can use a step before
And then we can
to
solve
get the velocity. So
the same way that we did before. So
the
V2
standard
is equal
flow
to,
rate.
and so the velocity is going to be 0.0012 divided by 3.14 times 10 to the negative 4, which is going to give us 95.54 meters. Now we have the two values for velocity, we can use Bernoulli's theorem. So it says that P1 plus 1/2 PV squared plus density of air times gravity times y plus P2 is equal to P2 plus 1/2 PV squared plus the density times gravity times second value of y. So because it's a horizontal tube, that means that y1 is equal to y2. So these two are the same, and we could divide both sides and cross them out. So now we can rewrite the equation. So P plus 1/2 times the density times V1 squared is equal to P2 plus 1/2 times the density times V2 squared. Then we subtract P2 from both sides, and we subtract 1/2 density times V1. And if we rewrite the equation, we're going to get that P1 minus P2 is equal to 1/2 of the density times V2 squared minus V1 squared. And so now we have found the value of P1 minus P2, which we can use in the other equation. So plugging in values, we're going to use the density of air for the density in the equation, and then just plug in the values for V1 and P2 that we found, and we're going to get that P1 minus P2 is equal to 832 pascals. Now we can get H, which is equal to 5,832 divided by the density times gravity. So I'm going to plug in the value of the density of mercury for the equation and gravity, and we're going to get that H is equal to 0.43 meters.